So let's get into this. It's a beautiful day because we actually have an implant for Predator that was uploaded to VT, which doesn't happen often. So found out about this yesterday. There was a blog post that was published by Google related to this. And yeah, we actually have a sample. So that's what we're going to spend some time on today is looking at this sample. Again, it's an iOS implant. The code insights here are actually pretty interesting. So it talks about what it targets. Not all of this is super accurate, but it does a good job of explaining things. So since its upload, I believe yesterday, initially it was undetected, and then of course things have changed since then. Here in the comments, we have posts for two different types of blog posts related to this sample. So again, we have this one, and actually earlier this year, iVerify went through the sample that we're going to be looking at, which is pretty cool. So let's dive in because there are a couple things in here that I want to highlight. We're not going to talk about the vulnerabilities that led to this implant even executing in the first place. That's beyond the scope of this video, and those are pretty advanced topics, and we're just not going to get into that. But we can talk about this part of it. And what we're going to focus on are, at least we're going to try to cover most of these behaviors here. So basically detecting if it's in developer mode, detecting if a console is attached, looking at the locale, looking to see if Cydia is installed, and all these things, right, that will basically tell this sample, this implant, that it shouldn't execute. So those are pretty interesting. iVerify does a good job of covering this stuff, which is pretty cool. I like how they cover the main function, which we'll look at, and they kind of summarize it here well. We'll talk about this 14 command line arguments thing. I actually got one of these parts wrong yesterday when I was looking at it, so that was pretty fun to look at. But yeah, so let's dive in. I'll refer to these blog posts if necessary while talking about the sample, but yeah, it's a good day. We actually have an iOS implant to analyze. So we're inside of the main function here, and the first thing that you'll see is all of these calls to stirred up, I don't know how you would call that, but essentially we can look that up really quick. So for anyone that's not familiar with this, save a copy of a string. It takes in two arguments, or one argument actually. So allocate sufficient memory for a copy of the string, does a copy, and returns a pointer to it. So this is going to return a pointer to this string that was passed in as the argument. Okay, so let's talk about that really quick. For anyone that's not super familiar with this, we're looking at a C type program. So the two arguments that are passed in the main function are going to be argc, the count of arguments, and then it's going to be an array of arguments, so argv here. And it's actually good to see this in a disassembly if we just kind of move all these over a little bit to make sense of this. So argv is the second argument to main, and that would be x1. So we see x1 is moved into x27 here, and then I guess we can use that as a reference. But essentially from there, we're referencing x1 or x27. So we have x1 referenced here. And this is going to execute this function, and then this return pointer for that string is then going to be saved into other registers. So how do we know that these are arguments that are passed to this binary, that are launch arguments in this case, that are being saved in this way? So we have x1 And now we're using this calculation for whatever x1 is pointing at plus 0x8. So we're dealing with an array. So argv0 is equal to the address of argv. In this case, it's equal to x1. So if we want to talk about the next pointer related to this array here, right? So we have an array of arguments that are passed to this binary. The next one would be argv1, which is equal to x1 plus 0x8. Why? We're dealing with 64-bit, so 8 bytes here. And that's going to give us the second launch, or actually it's the first launch argument. First launch, if I can spell that, arg. This will always be the exec binary path itself. And then you pass in each launch argument. So we're just going to add by 0x8. The next one will be 0x10 because we're dealing with hex. And then 18, 20, 28, 30, so on and so forth. And we're just copying all those launch arguments from this array into these variables, which are then used later, which is pretty interesting. So we can just put that there. Now that we know what we're looking for, this is going to tell us exactly what we saw, which is we're loading either using x1 or x27, because x27 has a pointer to that same array, right? We just moved over that address into x27. So we could just use x27 as our reference, and then we're just offsetting for each one of those launch arguments. And it's a lot. So let's just change this really quickly to make sense of it more. So again, this is going to be the first launch argument. So I'm just going to change this to arg1 or argv. And then, so that's argv1. So let's change that. Launch argv1. Okay, so launch argv2. This is going to take a long time, so I'm just going to kind of run through this. argv3 and launch argv boom 4, so on and so forth. And after all of these are completed, then we have this if statement that checks to see if they're equal to 0, which is pretty interesting. So if it's not 0, if this launch argument is not 0, so on and so forth for all these launch arguments, which end up being 14. So after that, we have another if statement that we're not going to talk about right now. We're going to do a comparison to the value that's in S1 here against the string watcher. So if we go back, we'll see, okay, so this is launch argument 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let me change this to launch argv14. Is going to be the 14th launch argument that was passed in. So this is a huge array of launch arguments that are passed when this binary is executed, which iVerify does cover. And I believe they even show a chart here that talks about different launch arguments. So we're dealing with this 14th one here, which you can see is an OR between this string and that string. So we're going to talk about that. We have a string comparison based on that launch argument 14. So it's going to check this launch argument. And this, from what we saw, should be either watcher or helper. So it checks for that. String compare is going to return 0 if they match. So if it's not watcher that was passed in as this 14th argument, we follow this if statement down to the else, where there's a check for the helper. And if that's not 0, then we just return. If not, then it sets up the helper class and launches these different methods against this class. So we're not going to deal with the helper right now. We might see some of it, but we're going to just continue. Let's say that the 14th argument was watcher. So now we're inside of here. And the next thing we have is a bunch of zeros are placed onto these variables, which we're not going to deal with right now. What we do care about is that we have this init method for the CS watcher spawner class that is executed. After that, we have spawn and start. So that's where we're going to continue. But before that, let's make sure we change some of these variable names here, because I got this wrong before. So we're passing in an address that was zeroed out. So I'm just going to put like init address for now. And if I change these arguments up here, which I know takes a while, but it's fine. I'll just like pause this really quickly and finish. All right, so we have all those now set up. Didn't want to spend too much time on that. And again, we have all of these being checked against the value of 0. And then all of these are passed to this init method, which is going to initialize this class. And there's a return value that's then used later. So we'll talk about that. There's like a couple checks here. All right, so let's go into this class. Okay, so now this is where I got confused yesterday. We have this address that was zeroed out, that was passed in as the first argument. So I'm just going to call this the init address. And then after that, we have all of these that are passed in that are launch arguments from the initial main function. So arguments that were passed when this binary executed. Now we have more of these duplicate string calls, and we're then going to use this init address and we're going to offset starting at 0x110, which is a pretty interesting way of doing this. So there's all this stuff prior to this offset that is not being written to. So we have launch argument 1, launch argument 2, 3, 4, 5, 6, 7. This one's important, which we'll talk about in a moment. So this is launch argument 7. So I'm gonna just make that clear. So launch arg 7. And that launch argument is then passed in to this stircat, so to concatenate two strings based on this bit path, which is the private var containers bundle path. And now we're going to concatenate that with whatever is passed in with this launch arg7. Okay, so that, and of course we're passing in a length, so we're just using +1 based on that string, right? So that we have enough space and we have that null terminator at the end. So that's pretty interesting because this bin path will then be concatenated with this additional value, and that's going to then create this binary path based on the launch argument that was passed in. So path with launch arg7. So when this binary executes at this specific part of this launch argument, there's some name that's passed in, and then it's added to this private var containers bundle. So the next thing we'll see is this init address plus 0x170. So that ends up being, we didn't see it the same way that this launch arg7 showed up. We didn't see this initialization here, but we can just see that that's ends up being arg13. So we can change that to arg13 or launch arg. Oh, yeah, let's just put that. arg13, and then we are doing another concatenation for this private var temp with using arg13. Okay, so this is another name of something that is added to this private var temp, and this ends up being the watcher path second. It's nice that they even have these variable names in here. Okay, so now the same thing is done here again, which is pretty interesting. And now we have that launch arg13 again. And that is then going to be concatenated with this private var containers bundle. So that's going to then set up the helper path based on, so concatenating to this. So that's pretty interesting. That sets up 3 different paths that are then going to be leveraged by this sample to do some checks and to verify that things exist on disk and all that fun stuff. So that will then change this because it's using that reference to this in the data section, and it's going to then concatenate these different names that are added to that. Okay, so that's how these launch arguments are used, at least for this init method. We can see that there's a breakdown of different launch arguments. Here we have number 7 being this name of the binary in the bit path, and we have this, which ends up being the name of the helper path. Okay, so continuing on from there, we have a bunch of other function calls that we're not going to talk about right now. This is going to initialize this class, so we're just going to go back. And we're going to talk about this spawn. So there's something I noticed here when analyzing this before. Binary Ninja does a pretty good job of like the decompilation here, making sense of it. But there are arguments that are passed to these functions that are not showing up here in the decompilation. So you got to spend a little bit of time in the disassembly because it's prettier. And you'll see that this same init address, which again was written to when we initialized, right? It was written to with all these different launch arguments before. And it's actually passed as an argument to this spawn method, right? So we actually have to change this to ensure that we reference that properly when we're editing our decompilation. So one way you can do that is like with the Y key. Press the Y key, this comes up. And we know that it's going to be an address that's passed in. So I'm just going to set the type to be this int 64. And I'm just going to put arg1 here. Now we can see that this init address is being passed in, which is going to be used by this spawn function too. So that's good to make sure that you're aware of that, because without that information, it would have been a little bit more difficult to see what's going on. So if we go in here, we have that arg1, and we can verify to make sure that there's an argument that's passed to this, not only based on the fact that we see x0 is given this pointer to this init address prior to the branch and link instruction here, we can actually see how x0 is used in the function call. So if we go there, we scroll down, x0 all the way at the top after the function prologue, which we don't care about. Oh, wait, this is an ARM64E. Don't really see this pack stuff usually because I mess a lot around with a lot of macOS samples, so I don't really see that. So that's pretty cool. So then we're saving this x0, that argument that was passed into x19, and that's used to then pass that same blob, that same memory address to these other functions. So these other functions actually also accept this. So we can just change that really quickly since it's technically wrong and it could help us understand the sample a little bit better. So arg1, and this is this init from init method. Okay, and then this is also going to get passed into this check performs, right? So we're moving the value in x19, which again was arg1 that was passed in here, in x0, and we're then passing this into these two functions. So the copy watcher and the check perform. So we just need to edit this in 64t. Again, we're passing an address, arg1. Okay, so now let's see what happens here. We're not going to spend too much time on this enable memory protection. It's pretty interesting. You can look up these function calls and see what it does. We're just going to get into more of the behavior. So that's cool if you want to spend some time on it. Copy watcher. So we have this, again, this is that init that was passed in. We're referencing this watcher path second, right? Which again had that concatenation that happened before. We're getting a stream to it, with write bytes or read bytes, sorry. We're f seeking to the end, so we're just grabbing that value from there, that helper, and it's just going to reference that watcher that was concatenated before, and it's going to return a pointer to that. Okay, so after that, we have the call to this check perform. This is pretty interesting. This goes into some of the behavior we talked about that was referenced in the Google write-up. So checking for developer mode, right? So like if you set up your iPhone in developer mode, there's a specific thing you can check for, and that's what they do. So let's talk about that. But first, we actually have a locale check. It's pretty interesting. Okay, so we have this, again, we have this init, and that is saved into X19, and that's used later down here, which is pretty interesting. And we have a bunch of calls to different types of checks. We can see that developer mode string here that's being passed in the sysctl by name, so it's checking for that. But let's start all the way at the top. So we have this utils class for the get counts names. I'm not too worried about this right now, but we can reference this. We can see this private var temp is being referenced here. And yeah, I'm not going to spend time on this one. But it checks to see if the return value of that is less than 2. And if it is, it's going to run all this stuff. So we can check this if statement. If it's greater than 2, it looks like it does a report abort thing here. So it probably just closes out. Okay, so next thing is console attached. It's pretty interesting. I don't spend a lot of time with iOS stuff. There's not a lot of samples that are released, but it doesn't access for this plist. So it's checking to see if this plist is on disk, and it checks to see if that is 0. And I forgot the return value of access. So man, access. Let me see value. Okay. So we're checking the existence of it. The value 0 is returned. If successfully completed, the value 0 is returned. Okay, so it's just checking to see if it's available, this plist. We're passing in this to the sysctl call. We're doing a stat, which again, here, man stat, display file status, returning there. And now we're doing so if it does exist, we are checking, we're using this NSData class to get the contents of the file for this plist. So this is going to be plist data. And then with this plist data, we're getting the plist from data. Okay, so we're just gonna get that plist information and return that. Okay, so is console attached? So based on this plist, it's checking to see, I guess that with the console being attached, it's related to this plist. That's pretty cool. The next thing that it does is this NS locale, which was talked about here, US or Israel, which is interesting. So we have this class for the NS locale. We're passing in the selector, auto updating current locale country code, and then we're getting that country code, and we're basically like piping that to a UTF-8 string so that we can get the country code. Okay, now there's a Boolean that's set here. So if country code is not equal to this, which ends up being US, so it didn't reference this US. So now it's showing it. Country code, you can just press like A when you see this reference. Country code, this value is going to be the return value of country code is equal to IL, which is Israel in this case. So I can also make this a string, and it will show up there a little bit prettier. So this is those checks that was talked about before. Does match. Okay, so it will return this true. So this is a Boolean value. If not true, so this needs to be true. So if, oh, that's always confusing. If it's not these, then continue. Okay. And then it does all this stuff. So let's talk about this. This is most of the behavior we've discussed already. We have this developer mode status that is checked here. And this var 0 is equal to, or is equal to 0. Okay, so it's checking to see if this exists with this call to sysctl. And if it does not exist, we continue. And we have this call to this method is not phone. Okay, so let's go in here. Okay, so now we have a bunch more calls to access, and we're checking when you pass in this 0, which I mentioned before, you're checking to see if this file exists. So we have if access, this JB paths exists is not equal to 0. And so this is a huge check to see if all of these exist. Okay, so we have bin bash, and I assume that these are all going to be right next to each other. E8, F0, F8, 00, 08, 10. So these are all next to each other. So I can just reference this one and then see what else is here. So we're checking for Cydia, it's APT thing, stash. Okay, we're checking for a bunch of these different tools, right? Which are all in this blob here. So jailbreak stuff, which makes sense if they're trying to infect the machine. I mean, an iOS device, and it's not trying to have, you know, researchers analyze this sample. Okay, so now it's checking, this is interesting, is using the NS file manager class, default manager, contents of directory at path, and it's passing in the bin path, and it's getting a count of those binaries inside the bin path. On iOS, I'm not sure what is actually there by default, so that's interesting. It gets the count, and we have, if the count is greater than 2, this is going to return 1. If it's less than 2, it's return 0. So this is going to return a Boolean value based on that. So checks to see if all this is on disk, or yeah, all these tools, which would indicate some kind of jailbreak, and is not phone, which is interesting. Okay, so if it's not 0, we go here, and that will end up at some point. We're not going to go into this right now, but is unsafe running is the next call. So we went over these checks for Cydia installed. We have other stuff here that's gonna probably get checked next. Okay, so is unsafe running. So unsafe procs, again, it's crazy that there's like actual variable names here. So we're getting the PID, I guess this utils class has this PID method, and it's gonna check, okay, so it's gonna check to see if these are actually running. So it's gonna be Frida, netstat, SSH, checkrain, and McAfee, Avist, and Norin mobile security. It's interesting that they're only looking at those. And I think those are down here. Yeah, okay. So it just checks to see if all these are actually executing, right? It's getting the PID, so they would have to be running, and it's checking against that. Okay, so is proxy running is pretty interesting. Okay, so I'm still not super familiar with like iOS stuff, but we have this system configurations preferences.plist, which just looks like same macOS one. And we are using an NS data class. We're passing in this data with contents of file. So we're gonna get this preferences plist, and we have this NS property list serialization, property list from data. So we're using this plist to get the data related to this. and it's going to look for this HTTP proxy using this return value. So plist data. Not sure why it has this weird number if it's not equal to. So we have this CF string for HTTP proxy and HTTP enable. So it's checking to see the value related to that and see if there is a proxy running. So that can indicate like some kind of tooling used by a researcher. Okay, is rootca installed? So we've checked the proxy, we checked to see if these tools are on the phone, and now we have this custom rootca. So this is here. This is pretty cool. So we actually have SQL commands. So we're getting the SQL command and we're doing the same string duplication call. So this is going to be SQLite command. And we're executing this query. So we're passing in this pointer to this string, and we're going to use the SQLite 3 APIs to open up this trustd private trust store SQLite 3 SQLite database, and we're going to execute this command at some point. The command would be in arg1. Not sure how that gets run, but let's move this over. So we have, let me make sure that's right. So SQLite command is the first argument, so a pointer to that. And we actually have, there's 3 arguments that are passed here because we have x1, x2, and x3. So let's go back. It seems like this is wrong. So here, and then we are in check perform, and we are in is rootca installed, execute query. Yeah, so this is wrong. We're actually missing an argument here. So the way that you can check for that is we know x0 is this string that was returned from this string duplication function call, which is moved into x1. And then we have this 5, which is moved into w2, which ends up being the 3rd argument passed in. Not that it's that big of a deal, but still interesting. 32 tr3. Boom. Okay, so now we have that 5 there. Now that makes a little bit more sense when I was seeing this here. Okay, but at some point this x20 is moved, and where exactly is it used? It's used here for the preparation call. Okay, and arg1, which is x0, is compared. Okay, it's like overran with this. Okay, so we're opening up this SQLite database, and at some point we're going to pass in this argument to then execute that SQLite command, which is pretty cool. And it's going to check for, I don't even know what this is supposed to look for in there, but I guess this is related to rootca's. We also have this command, select tset or something. Okay. So it's going to execute that again, and the return value again is this is a Boolean, is going to return 1 or 0. We actually have that comparison here. Cool. So that covers a lot of these behaviors, which is pretty interesting. There's more here that we're not going to get into. It looks like the helper module has more interesting things that it may do. The watcher looks like it's more in charge of ensuring that it's not executing on some kind of test device, and it's just checking all this stuff. So this is inside of the check performs call, which we can go back because we're inside of this spawn method. Here, it's going to do a bunch of checks, and then it does this download executable, which is pretty interesting. Oh, so we have this watcher file path before that, this stream. And this is going to then be used at some point. But we have this download executable that will then go out and actually download another executable. But the way that it does that is pretty interesting. So first, this is wrong because x19, which is saved all the way from this init method, is actually going to get passed to this. We can see that change happening here, x19, x0. So we have to change this again. So int 64tr1. Okay, so here's how you know where this was pretty cool. So going back to iVerify's thing, they know that the first launch argument is the URL. Now, how do you know that? You actually see it here, which is pretty cool. Again, remember, this is the init from init method that was written to all the way back for this class when it was initialized, and it had the launch argument saved to this address at like a crazy offset. The hex 110 was the start of it. So we're checking to see if it's not 0. If not, we're returning. If that's not the case, then we're doing this. So we have this ns string with UTF-8 string, and we're getting this value init from init method plus this offset. Now, if you're not taking notes, like I wasn't, you would forget what this is. So in order to understand what this is, that it is dereferencing in order to create a C string, you have to go back. So you can kind of get a hint, right? So this is going to be, if you just change this variable name, so this is string from address. And then if you just look at where this is passed, URL with string, you know that this is going to be a URL of some case. And this URL is then passed to this data with contents of URL. And this is going to create an NS data object, which is actually going to go out and grab whatever this is from this URL, and it's going to download it. Downloaded data. And then there's checks to see like the bytes here. It actually, that's interesting. It puts the bytes in this same blob of memory, which is pretty cool. And it has the bytes and the length are actually stored here. And then, yeah, that's pretty cool. Oh, and then it adds a 0 at the end of it. Okay. So we have to understand what this is. So we actually have to go back, right? So this offset, if you didn't already know that was the URL that was passed in, we go back. So let's use our references here. We have this call, download executable. We're going to go back to the init method all the way in main. This is the init method here. And we just needed to look for that hex 110. This is the URL. URL passed in as first arg. Let me make that more clear. First launch arg. So sometimes you got to come back. I had to come back to this init method a few times to see like what was what. But yeah, so that is going to be the first. And how do you know that that is the case? This arg2, we go back to the main function. We have that init address that's passed all over the place here. And then we have that second argument, which ends up being this argv1, which if you go up, argv1 would be argv plus the offset of 8, which is going to be the first launch argument. argv plus 0 would be the binary that's executing, right? So we talked about that up here. So first launch argument, that's cool. All right, went over a bunch of stuff here. We were back in the spawn download executable. So that's going to then download that. And then we're checking to see if this watcher path second exists, which again, this was concatenated before. If it exists, if it's 0, removes it. Else if it removes this other one, which is the path second. Okay. And then it does this check agent. Then we get into some more stuff here that's pretty interesting. So cover this really quick because I think it's kind of going a little long, but that's fine. So check agent, we have this NS file manager, attributes of file at path. So it's getting the attributes of this Ethereum text file. So Ethereum path attributes. Oh, cool. It's going to check the modification date of this. So file modification date, mod date. And then it gets this NS data for the date since the mod date. Oh, actually, I think this was talked about in the iVerify report. Let me see if I can find it really quickly. Yeah, here. Ethereum text older than 45 minutes. That's cool. So it checks for that. And execute downloaded. So thankfully we have actual method names here that tell us what's going on, and we can kind of guess what this ends up doing. It will end up executing another payload, opening binary. That's pretty interesting. There's a lot going on in this function. We're not going to deal with that right now. Spawn directly, write file. That's cool. All right, so kind of went over a lot of the behaviors. This is a pretty awesome blog post here that goes over the sample if anyone wants to kind of poke around with this. We don't usually get an iOS implant to look at, which is pretty cool. And this does a really good job of providing a lot of context related to how we even get to this point. I think it's pretty interesting, especially for those that are interested in like vulnerability stuff. Again, outside the scope of this specific video, but just wanted to go over these behaviors and how to look for them. There's no obfuscation, but again, on iOS, I don't know, there's not a lot of this stuff that even executes on iOS. So if you get to this point, I guess threat actors are not really concerned about obfuscation. So it is a really good sample to take a look at and see more iOS stuff, especially if you're familiar with macOS. It's been a lot of fun, but hopefully that's helpful. There's a lot that I didn't cover, but I'm already pretty long into this video. So, all right, that's it.